Okay, we'll pick up with problem number 4 here. In problem 4, we want to solve each inequality and write your answer using set notation or interval notation. And that's how the book is going to want this also, and that's how we should give our answers. Okay, so like you're not done with the problem yet until you have the answer written as a set or as an interval. Okay. So part A, we got -3 times 4x minus 4 greater than or equal to 4 minus the quantity x minus 1. Solve for x. Okay, so if I distribute -3 on the left, I got -12x plus 12, which is greater than or equal to 4 minus x plus 1. Okay, and then anything involving x, let's get on the left. All the other numbers, let's get on the right. 4 plus 1 is 5, right? And then when I subtract 12, 5 minus 12 is -7. I'm also adding x to both sides. -12x plus x is -11x. So then the next thing would be to divide both sides by -11. Okay, now here's one very important thing. So whenever we multiply or divide both sides by a negative number, we have to flip the sign. Okay, make sure that you do that. And you know, a common mistake with these problems is that students don't remember to flip the signs and they get a wrong answer. You know, so because I'm going to divide both sides by -11, I have to flip the sign. Okay. Otherwise, what I'm saying is not true. So, like, if I just give you a simple example here, 2 is bigger than 1, right? So if I multiply both sides of this by -1, -1 is on the left, and -1 times 2 is -2. That's on the right. Now, which number is the bigger number? Well, it's -1. You know, so I have to flip the sign. Otherwise, if I don't, I'm not saying something that's true. Okay, and if we look at this again, 1 is less than 2, right? So if I divide both sides by -2, 1 over -2 is -1/2, and 2 over -2 would be -1. Okay, which side's the bigger number? Well, it's going to be the left side. -1/2 is bigger than -1, so I have to flip the sign there. Okay. So why we're flipping the sign is to make this statement still be true, okay? And my answer has to be written as a set or as an interval. So as a set, I'd say the set of all x such that x is less than or equal to 7 over 11. Okay, and then that'd be the answer. Now, you're not done with the problem yet until you have the answer written as a set or as an interval. Okay, so I wouldn't just circle this guy here, and call it good. I mean, like, unless I want to lose points, make sure that the answer is written as a set or as an interval. Okay. Part B, we want to solve this inequality. So let's begin by multiplying both sides by -10. We'll have x plus 5 on the left, and then -10 times 2x plus 3, that'd be -20x minus 30. Okay, now we just multiplied both sides by a negative number, so I have to flip the sign there. Okay. Next, if I add 20x to both sides and then subtract 5, then 21x would be on the left. -30 minus 5 is -35 on the right. And then divide by 21. We're dividing by a positive number, so we don't flip the sign there as long as if you multiply or divide by a negative. -35 over 21. 7 goes into both those numbers. So 7 times 5 is 35. 7 times 3 is 21. It'd be a -5/3. Okay, x is less than -5/3. Okay, so my answer is going to be the set of all x such that x is less than -5/3. Okay, any number in this set, you know, if I plug that into the original inequality, I'll have a true statement. Any other number that's greater than or equal to negative 5/3, if I plug that in, I'll be saying something that's false. Okay. Here's some more of these. So part C and part D, I'm solving what's called compound inequalities, or three-part inequalities, as sometimes we say. So there's a left part, a middle part, and a right part. Right? Let's see, to solve a three-part inequality, I can split it into two inequalities. I can say -1 less than 1/4 x plus 3, and 1/4 x plus 3 is less than 2. And is a key word there. Okay, we'll talk more about that later on in this chapter. So then I'll subtract 3. -1 minus 3 is -4. And I'll multiply both sides by 4. And because I'm multiplying both sides by a positive number, I don't flip the sign, right? So -16 is less than x. Okay, and go ahead and write that keyword down. That's you know, key for the problem. Again, we'll talk more about these key words, like whether we have an and statement or an or statement, a bit later in this in the chapter. Okay. So right now, whenever we have a compound inequality and we're solving, we have to write the word and. Okay. And so then over here, if I subtract 3 and then multiply by 4, I'll have x less than -4. I'm multiplying both sides by a positive number, so I don't flip the sign there, right? Okay, so what we're saying is that x has to be a number that is greater than -16 and less than -4. Okay, as a set, I'd say the set of all x such that x is greater than -16 and less than -4. Okay, and that'd be my answer. Part D, I have another compound inequality here. Now, you don't have to split the compound inequality. If you do split it, you have to write the word and down. Okay, you don't have to split it though, because the reason is why split it if you're just going to put it back together again anyway, you know? And like the more you do with this stuff, you know, you're not going to be splitting these inequalities if you just put them together at the end anyway, right? So now if I'm keeping this as a compound inequality throughout the whole calculation and I'm not splitting it, then the goal is to get x all alone in the middle, right? So let's go ahead and subtract 1 from throughout the three parts here to start. -2 minus 1 is -3. 1 minus 2x minus 1 is minus 2x. And then 3 minus 1 is 2. The next thing, if I divide both sides, or if I divide throughout the three parts there by -2, I'm dividing by a negative, so I got to flip these signs here. And, you know, make sure that you're flipping both the signs, okay? -3 over -2 is 3/2. Greater than or equal to x, and that's greater than 2 over -2 is -1. Okay, so my answer, you know, as a set, I'd say the set of all x such that x is bigger than -1 and less than or equal to 3/2. Now, I could have, if I wanted to, said the set of all x such that 3/2 greater than or equal to x greater than -1. That'd be fine. You know, you're still saying the same thing. But usually, when you're reading a mathematical statement, usually you'll see the smaller numbers first and then the bigger numbers second. You know. Now, if I'm using interval notation, which would be fine, you know, then the order matters, right? So I'd have to say -1, comma 3/2. There'd be a parentheses by -1 and a bracket by 3/2. Okay, so Okay, either form is fine, set notation or interval notation. Okay. So then problem 5, we want to find the x and y intercepts for the equation 6y plus 7x equal negative 21, and then use them to graph the line. Okay, so we have a line here, and to find the x-intercepts, we need to let y be 0 and solve for x. To find the y-intercepts, we need to let x be 0 and solve for y. So whatever kind of intercept you're wanting to find, let the other guy be 0 and then solve for that variable. Okay, so to get the x-intercepts, let y be 0. Okay, 6 times 0 is 0. And 7x equal negative 21 divided by 7. So x would be negative 3. Over here, to get the y-intercepts, let x be 0. 7 times 0 is 0. And you got 6y equals negative 21 divided by 6. So y would be negative 21 over 6, and that reduces to negative 7 halves. Okay. Then the intercepts are points on the graph where you're going to cross or touch the x or y axes. Okay, so let's see, we got x to be negative 3 when y was 0. So the point negative 3 is 0 is going to be on the graph. And then over here, to get the y-intercepts, we let x be 0 to get y. So 0, negative 7 halves, that's going to be the y-intercept. Okay, so I'll go ahead and plot these 2 points. Here's negative 3, 0. And then 0, negative 3.5 or negative 7 halves, that's the same thing. That'd be right there. Okay, and then, you know, like as long as these 2 points are somewhat distant from each other, you know, you can use those 2 points to then draw the line. Okay, so the intercept method is a perfectly good option to use to draw lines. Okay, we also need to know the slope in the y-intercept. Okay, that's a very common method for graphing lines also. Okay, so why don't we stop the video right here, and in the next video I'll talk about slope and slope-intercept form is the form that we'll use to give equations of lines.